Alright guys, so if you've ever wondered what the inside of an electric motor looks like, look no further because I have the video for you. This is a 200 horsepower 3-phase electric motor. It's pretty large, but it's not uncommon to see electric motors get into the 5,000, 10,000, 20,000 plus horsepower range, but I rebuild these things for a living and I'm going to show you how we do that. The first thing I need to do is I need to strip out all this original copper wire. While doing so, I need to count these wires because we need to put back in what we took out. If we start changing data, if we use the wrong size wire, the wrong number of turns, the wrong span, even if we put the wrong shape of coil in there, we can start having issues with these things. What you're looking at in this frame is a Bimetallic Overload. I use that term loosely because some people call them thermistors, some will call them heaters, but they do actually make heaters to go inside of these, keep condensation out of the motor itself if it sits for extended periods of time. There should be at least one of those per phase, so if we have 3 phases, we should find at least 3 of those in this winding. And the purpose of that is that we might have an imbalance in voltage, which is causing an imbalance in current, so we could have our A phase drawing more current than our B phase, which is going to heat up hotter, so we need to monitor each one of those. We need to make sure not one is overheating versus the other. This had about 300 pounds of copper in it. So this is the end of where I started. I need to pull all these coils back up and out, because I need to continue laying underneath of these. Then I will lay those back on top of what I'm about to lay in there. Some people don't do this, they just continue laying over that, which is called lazy lap winding. There's a good reason not to do that, and one of them is uneven cooling. You guys will see sometimes I'm holding these wires while I'm making these coils, and I came across a little guy today where you can see that the enamel coating, this is our insulation, this is our dielectric strength of this wire, is thinning right there. That's why you can see more of the copper color. So I have one more coil to insert, and you can see right here where I got that paper. This is usually the hardest one to get in. After that, where it's kind of the final countdown while we're almost done. I did manage to squeeze that coil in there. So we'll insert this last coil, then I'll go ahead and drop those tops. We'll get the winding completely in place. I'll show you what it looks like before the connection is done. If you haven't already, guys, go follow me on Instagram. There's a link in my TikTok bio. I post high-resolution photos of these things on there. If you're not following me, hit that plus button. I'll post a video of this thing running. You can see a size comparison of that next to that water bottle sitting on that cart. Ultimately, this is going to come out as 3 leads as a 460-volt, 4-circuit delta pulling 218 amps. Cheers, guys. Follow.